Tonight, we uncover a 50-year-old cosmic crime scene that threatened to unravel the very foundation of reality. For half a century, the brightest minds on Earth have been haunted by a terrifying possibility. We were told that black holes were the ultimate incinerators, dark abysses where the light of dead stars, the memories of ancient worlds, and the fundamental code of the universe were dragged into a bottomless pit and erased forever. If that were true, reality itself would possess a delete button, rendering our past meaningless and our future completely unpredictable. But what if we were wrong? What if the void isn't a grave, but a vault? Out there, spinning silently in the dark, the black hole has been holding on to a secret that changes everything we thought we knew about space, time, and the immortal nature of information. We like to believe that the universe keeps a perfect record. In the quiet, microscopic realm of quantum mechanics, there is an ironclad law, a foundation upon which the entire architecture of cause and effect is built. It is called unitarity. Unitarity demands that information is immortal. It states, with mathematical certainty, that the present state of the universe must perfectly encode its past. You can burn a book to ash, you can shatter a diamond into dust, or you can scatter a planet across the expanse of a galaxy, but the fundamental quantum blueprint of every carbon atom, every trace of heat, and every whisper of smoke remains intact. In principle, with a powerful enough quantum computer gathering every scattered piece of that dust and light, you could seamlessly reconstruct the pages of the destroyed book. The physical form changes, but the information, the deeply encoded memory of what was, survives. It is perfectly conserved. It is eternal. But 50 years ago, a shadow fell over this comforting certainty. In 1974, Stephen Hawking looked into the absolute darkest regions of space and mathematically discovered a dead body. He realized that black holes, the great silent titans of gravity, are not completely black. They leak. Through the subtle, vibrating jitter of the quantum vacuum near the boundary of the event horizon, particles are constantly coming in and out of existence. Hawking showed that occasionally one of these entangled particles falls inward, while the other escapes into the vastness of space. This faint, thermal glow, a gentle rain of subatomic fragments bleeding out into the void, came to be known as Hawking radiation. And with this radiation, the black hole slowly loses energy. Over unfathomable aeons, stretched across trillions upon trillions of years, these majestic giants will evaporate completely, dissolving into nothingness. At first, this discovery seemed like an elegant, peaceful conclusion to the life cycle of a collapsed star. But then came the terrifying realization. The radiation seeping out of the black hole was entirely featureless. It was calculated to be completely random thermal noise. It contained absolutely no trace, no memory, and no blueprint of the matter that had fallen inside. If an entire star, complex planets, or the intricate data of a living world were swallowed by the abyss, they were converted into this random scrambled glow. And when the black hole finally evaporated into the quiet vacuum of space, the information of what it had consumed did not return to the universe. It was simply gone. This was the cosmic crime. It was the murder of information. If Hawking was mathematically correct, the universe possessed an irreversible delete button. It meant that the history of collapsed stars, the state of every drifting atom that ever crossed the event horizon, was permanently wiped from the ledger of reality. Prominent physicists recognized the catastrophic implications immediately. Leonard Susskind and Gerard 't Hooft saw that if Hawking were right, the very foundations of physics would collapse. If the present does not perfectly encode the past, then cause and effect are illusions. The universe would become inherently flawed, governed by a creeping, unpredictable amnesia. For decades, this existential crisis, known as the black hole information paradox, stood as the greatest battleground in modern science. It ignited the black hole war, a decades-long intellectual struggle between the two great pillars of physics. On one side stood general relativity, describing the curving, heavy fabric of spacetime. On the other stood quantum mechanics, guarding the microscopic rules of matter and immortal memory. Physicists became detectives working a cold case that spanned the cosmos. They stared into the mathematics of the void, desperately looking for where the missing information went. During these dark ages of the paradox, desperate theories began to emerge from the academic underground. Some suggested that the information was left behind in a microscopic remnant, a tiny, eternally stable nugget of infinite density that somehow survived the evaporation process. Others proposed that the information was shunted out the back door of the singularity, spilling into a parallel universe, forever lost to us, but technically preserved in some unreachable dimension. These were the theories of a scientific community standing at the edge of the abyss, terrified of what the darkness implied. The black hole seemed to be a relentless vacuum of doom, wiping the universe clean and leaving no trace. The detectives kept turning over the same evidence, searching the thermal glow for any sign of life, any whisper of the past. The hours ticked by, and the case grew colder. But the universe is rarely as cruel as our deepest fears suggest. The cosmos does not forget so easily. What seemed like a closed case, a final verdict of total destruction, was simply a profound misunderstanding of how the universe compresses its memories. The murder never happened. The information was not destroyed in the singularity, nor was it banished to another reality. It was simply in hiding, waiting for us to understand the silent, patient language of the horizon. To truly understand how the universe keeps its most profound secrets, we first need to understand what it is that is actually being hidden. When we whisper the word information in the quiet, drifting realm of quantum physics, we are not talking about words written on a page or the numbers in a digital file. We are talking about something much deeper, something fundamental to the very fabric of existence. Information is the precise, delicate arrangement of the particles that make up everything you see, everything you touch, and everything you are. Imagine for a moment a handful of carbon atoms drifting softly in the dark. If you arrange these atoms in one specific, structured way, they bond tightly together, and you get a dark, heavy lump of coal. If you take those exact same carbon atoms and you simply shift their arrangement, pressing them into a different crystalline lattice, the dark coal transforms into a brilliantly clear, shimmering diamond. The fundamental building blocks, the atoms themselves, have not changed at all. They are identical. What has changed is the information. If we were to gather even more atoms, billions of them, and weave them into a complex, spiraling biological pattern, we could form something entirely different, like a banana, or a living, breathing squirrel sitting in a quiet forest. The universe is fundamentally composed of the same drifting subatomic dust. A carbon atom does not know, nor does it care, whether it is currently part of a drifting cloud of interstellar smoke, a smooth grey stone, or the warm, beating heart of a living creature. The only difference between the stone and the heart is the information, the specific, deeply encoded memory of how those pieces were assembled. Information is the blueprint of reality. Without it, everything in the vastness of the cosmos would be a featureless, identical smear of grey. Information tells the universe how things are different from each other. And for decades, as we stared into the pitch-black shadows of collapsed stars, we believed that black holes did the exact opposite. We believed they took beautifully different things, swallowed them, and crushed them until they were all exactly the same, destroying their unique information forever. We viewed the black hole as the ultimate cosmic trash can, a bottomless pit of erasure. But nature is far more elegant and far more protective of its memories than our initial fears led us to believe. In the 1970s, a physicist named Jacob Bekenstein was looking closely at the mathematics of these silent, spinning giants, and he asked a deceptively simple question: how much information can a black hole actually store? At the time, classical physics viewed the black hole as pure, featureless geometry, a region of warped space and time completely devoid of any internal structure. If it was just empty, curved space, how could it hold on to the memory of anything? But Bekenstein discovered something magnificent. He realized that a black hole does possess a memory, and its capacity is mathematically defined not by the immense, dark volume of its interior, but solely by the surface area of its outer boundary, the event horizon. To feel the profound strangeness of this, imagine the quiet room you are resting in right now. If you wanted to know how much information you could safely store inside this room, how many physical books you could stack from the floor to the ceiling, you would naturally measure the physical space inside it. You would calculate its three-dimensional volume. But the universe whispered a remarkably different rule for the black hole. Nature quietly declared that the ultimate storage capacity of a region of space is determined only by the two-dimensional boundary surrounding it. It is as if you could paper the flat, two-dimensional outer walls of a vast, towering library with the deeply encoded contents of every single book ever placed inside, leaving the actual interior of the building entirely, perfectly empty. Let us imagine a room filled with baskets of laundry or perhaps boxes of ancient archives. The more you want to store, the more baskets you place inside, but eventually you reach a threshold. The room becomes completely stacked, filled to the absolute brim until not a single microscopic thread can be added. The room is at its maximum possible capacity. If you were to force even one more piece of information into that densely packed space, applying immense pressure and violence to squeeze it in, the room would collapse in on itself, forming a black hole. Its internal capacity has reached the absolute limit of what three-dimensional space can hold. So what happens when you continue to throw more information into the dark? The universe offers a breathtaking solution. The event horizon itself gently swells. The black hole grows its surface area, expanding by 1 microscopic pixel for every single bit of data it consumes. When an object slips past the threshold, it is as if you have thrown a heavy stone into a deep, still pond. The stone sinks to the bottom, vanishing into the pitch-black water where you can no longer see it. But the event does not go unrecorded. You can tell that something entered the water, and precisely how heavy it was, by reading the intricate, shimmering ripples that fan out across the two-dimensional surface of the pond. The event horizon of a black hole is that shimmering surface. The microscopic pixels expanding on the edge are measured in square Planck units. The Planck length is the absolute smallest distance that can sensibly exist in the fabric of reality, a scale so unimaginably tiny that a single proton would look like an entire galaxy in comparison. Because these pixels are so unfathomably small, even the smallest black hole drifting alone and unnoticed in the void can patiently store more information on its smooth, dark surface than all the data, all the books, and all the digital archives ever produced in the entire history of human civilization. This realization birthed what physicists call the holographic principle. When you look at a traditional hologram, you are looking at a flat, two-dimensional piece of plastic film. Yet, encoded within that flat surface is all the necessary, intricate information required to project a fully realized, deeply textured three-dimensional image into the air. The boundary of a black hole operates in the exact same way. We must entirely redefine how we view the event horizon. It is not a violent threshold of doom. It is a massive two-dimensional server rack. It is patiently storing our complex three-dimensional reality in pixelated subatomic code. If an astronaut were to fall into the abyss, they would experience their usual three-dimensional existence as they drifted smoothly downward. But from the perspective of the outside universe, the essence of who they are, the precise quantum arrangement of their carbon atoms, their memories, and their warmth is flattened and encoded as an image resting gently on the surface of the black hole. A black hole is simply the universe's ultimate hard drive. It is a cosmic zip file. Think of taking a towering physical library, tens of thousands of heavy paperbacks, and effortlessly compressing them into a sleek digital e-reader. The physical form changes dramatically, but the content, the stories, the knowledge, and the information remain completely untouched. It is simply encoded and memorized in a different way. When a black hole swallows an ancient star or pulls in a wandering planet, it is just transferring a physical library into an immortal digital format. This shifts the narrative of the cosmos from one of existential dread to one of profound, lasting comfort. We live in a universe that does not waste its past. When massive stars burn out, when planets crumble and fade into the freezing dark, the universe does not press delete. It gracefully compresses its history. Every drifting atom, every ray of light, and the microscopic blueprint of all that has ever existed is safely caught and backed up on the edge of these collapsed stars. Our universe is not flawed by a creeping amnesia. It is a meticulous, perfect archivist. Nothing is ever truly lost, not your memories, not your past, and not the light of dead stars. The universe remembers everything, and still the black hole spins, silent, patient, remembering. For much of the 20th century, physicists were trapped in a deeply unsettling assumption about the deepest shadows of our universe. When they looked at the mathematics of the event horizon, they did not see a canvas of cosmic memory, but a sheer, impenetrable wall. In classical physics, there existed a rigid and terrifying concept known informally as the no-hair theorem. This theorem dictated that a black hole was completely featureless, defined entirely by only three simple properties: its mass, its electrical charge, and its spin. According to this old, haunting view, the black hole was perfectly bald. It possessed no distinguishing features, no surface texture, and absolutely no individuality. If you were to take a brilliantly shimmering star, a wandering planet composed of intricate geological layers, and a quiet drifting cloud of interstellar dust, and throw all three of them into the deep gravity of a black hole, the outcome would be identical. The unique, delicate identities of these celestial bodies would be entirely stripped away, washed down into the dark. The black hole would only register the total amount of mass that was added, perhaps shifting its rotation slightly, but it would offer no clue as to what had actually fallen inside. It would simply grow larger, presenting the exact same smooth, silent face to the outside universe. This was the terrifying essence of a universe that forgets. It meant that black holes were cosmic erasers, silent voids drifting through the aeons, actively destroying the beautiful complexity of the world and leaving behind only a blank, heavy geometry. For decades, this idea haunted the scientific community. The thought of a perfectly bald black hole was the source of immense existential dread, implying that reality itself was inherently flawed, quietly slipping into an irreversible amnesia. But as the years flowed on, the greatest minds of our time refused to accept that the universe would simply delete its own history so carelessly. They searched for a flaw in the smooth, featureless mask of the event horizon. And in the twilight of his life, before his passing in 2018, Stephen Hawking offered the world a final, profoundly beautiful theory. Working in quiet collaboration with his colleagues Malcolm Perry and Andrew Strominger, Hawking sought to mathematically disprove the terrifying concept of the bald black hole. Together, they peered closely at the boundary of the void, looking past the sheer gravity down into the whispering, microscopic realm of quantum mechanics. What they discovered changed the nature of the horizon forever. They revealed that black holes are not smooth, featureless voids at all. Instead, they proposed that black holes possess what they called soft hair. This soft hair is not made of any physical substance we can easily touch or feel. It is something far more delicate, far more ethereal. It is an infinitely fine, invisible sheen of zero-energy photons and gravitons gently coating the entire spherical boundary of the event horizon. These are particles of light and gravity that possess no measurable energy, allowing them to hover in perfect, weightless suspension directly on the edge of the abyss. They form a shimmering, highly sensitive halo around the black hole, quietly waiting in the dark. We must close our eyes and reimagine the event horizon. It is not an empty threshold of doom. It is an ultra-high-definition, pixelated screen waiting to record the passage of anything that touches it. When an object begins its slow, drifting descent toward the black hole, crossing the vast, silent stretches of space, it eventually reaches this shimmering boundary layer. As the object slips past the point of no return, crossing the threshold into the dark interior, its three-dimensional physical form continues to fall inward. But its passage does not go unnoticed. As the object slides through the delicate sheen of soft hair, it leaves behind a permanent, two-dimensional holographic imprint on the surface of the event horizon. The unique, microscopic blueprint of the object, the precise quantum arrangement of its atoms, the memory of its structure, the whisper of its past, is eternally stamped onto this boundary. The physical matter passes through the veil, but the information, the true essence of the thing, is safely caught in the soft hair, resting gently on the surface of the black hole like a fingerprint on glass. Imagine billions of years passing. Imagine unfathomable aeons drifting by in the quiet dark, as galaxies slowly turn and ancient stars burn down to embers. The black hole sits in the silence, incredibly patient, holding on to these holographic imprints. It is a cosmic archive, a vast spherical library where the covers of the books are perfectly preserved on the exterior walls, catching the faint, shimmering starlight of the universe. The memories are completely safe, encoded in these zero-energy photons, forming an intricate, pixelated mosaic of everything the black hole has ever encountered. But the story does not end with preservation. The universe requires a way to share these memories, a way to breathe the lost information back into the drifting currents of reality. And this is where Hawking's theory of soft hair perfectly aligns with his earlier discovery of the slow, thermal evaporation of black holes. As we have seen, the black hole is not entirely dark. Through the gentle, continuous jitter of the quantum vacuum, it slowly leaks energy, releasing a very faint, incredibly cold glow of particles known as Hawking radiation. For a very long time, physicists believed this outgoing radiation was completely random, a featureless noise that carried no secrets from the deep. But the soft hair changes everything. As the black hole slowly, patiently evaporates over trillions of years, it bleeds its energy back into the freezing vacuum of space. The outgoing thermal radiation must push its way past the event horizon to escape. And as it does, it brushes against the soft hair. Imagine a soft, gentle wind moving slowly through a dense, quiet forest. As the breeze flows through the trees, it rustles the leaves, picking up the subtle scents of the pine, the damp earth, and the delicate flowers, carrying those whispered secrets out of the woods and across the open plains. The escaping Hawking radiation acts exactly like this cosmic wind. As the particles drift outward, escaping the pull of the black hole, they gently brush against the shimmering sheen of zero-energy photons and gravitons. In this delicate interaction, the outgoing radiation picks up the encoded information resting on the surface. The thermal glow is imprinted with the two-dimensional blueprints of the past. The radiation absorbs the memories, the quantum data, the intricate codes of fallen stars and drifting planets, and safely carries them back out into the vast, open expanse of the universe. It is the cosmos's ultimate copy and paste mechanism. The information is delicately translated from the surface of the horizon into the escaping light, riding the waves of radiation across the galaxy. This realization washes away the existential dread of the featureless void. The universe is not a careless place. It does not erase the beauty of its own creations. The black hole is not a grave, nor is it a blind, hungry destroyer. It is a meticulous, gentle conservator. It catches the drifting matter of the cosmos, carefully translates its unique identity into a holographic memory, and then, with the infinite patience of deep time, slowly whispers that memory back into the dark through the softly escaping radiation. We can find a profound, deep comfort in this mechanism. When we look up at the night sky, we do not need to fear the dark, heavy shadows spinning at the centers of the galaxies. They are engaged in a slow, peaceful process of cosmic archiving. They are keeping a perfect ledger of reality, ensuring that the quantum history of the universe is protected. The sheer elegance of this exchange, the physical matter falling inward, the holographic memory resting on the surface, and the soft wind of radiation carrying it away, shows us a universe that is deeply interconnected, beautifully structured, and incredibly protective of its past. Nothing is ever truly lost. The universe possesses an endless capacity for memory, woven into the very boundary of space and time. Even in the presence of the most extreme gravity, the delicate sheen of soft hair stands as a testament to the immortality of information. The light of dead stars, the remnants of ancient worlds, and the exact arrangement of the universe's past will drift onward forever, safely translated and returned to the cosmic flow. And still the black hole spins, silent, patient, remembering. The universe is a vast, quiet tapestry woven from invisible threads. If we zoom out to the grandest of scales, we see the sweeping, heavy curves of gravity, the slow, majestic orbits of wandering planets, and the drifting, glowing dust of ancient nebulae. But to truly understand how the cosmos protects its most delicate secrets, we must utilize the overview effect, leaving the towering, macrocosmic architecture of the event horizon far behind. We must zoom in past the swirling dust, past the heavy celestial bodies, and slip softly down into the unfathomably tiny, whispering realm of the quantum foam. In this microscopic space, the rigid rules of our waking reality soften and blur, guided instead by delicate, invisible relationships. It is here, in the quiet dark, that we must meet Alice and Bob. Alice and Bob are not human, but their story is one of the most profound and deeply tragic romances the cosmos has ever written. They are twin subatomic particles born together from the exact same microscopic spark of energy in the deep, freezing vacuum of space. Their birth is a quiet, invisible event, a sudden flaring of energy in the dark, but it binds them in a way that defies all everyday understanding. Because they share this single, unified origin, their fates are perfectly, eternally intertwined. They exist in a beautiful, delicate state known as quantum entanglement. To understand the true depth of their bond, imagine a single, shimmering quantum coin. If this coin is spinning in the dark, it exists in a fluid state of possibility, a beautiful superposition where it is simultaneously both heads and tails. If you were to carefully split this spinning coin in half, giving one piece to Alice and one piece to Bob, and send them drifting across the galaxy in opposite directions, their connection remains entirely unbroken. If Bob eventually catches his half of the coin and observes that it has landed on heads, he instantly, mathematically knows that Alice's half is resting perfectly on tails. Regardless of the vast, cold oceans of space separating them, they act as a single, mirrored system. The universe weaves an invisible thread between them, ensuring that whatever happens to Alice is perfectly mirrored by Bob. They are two halves of a single, unified whisper in the dark. For countless aeons, Alice and Bob drift together through the cosmic silence. They travel across the unfathomable emptiness of space, a flawless, symmetrical partnership moving gracefully through the expanse. They slip past the fading light of dying stars and ride the gentle, undulating ripples of gravitational waves. Their bond is absolute, a silent promise kept across billions of light years. But the universe is a place of shifting geometries, and gravity is an incredibly patient architect. Eventually, their drifting brings them to the steepening slope of a curved space-time geometry. Ahead of them, resting silently in the void, is an ancient black hole. From a distance, it does not look like a violent monster. It has no visible features, no sudden, dramatic pull. It is simply a region where the fabric of reality has folded gently inward, like a heavy weight resting on a stretched rubber sheet. The black hole does not act like a cosmic vacuum cleaner aggressively sucking things in. It is merely a quiet shape in the dark. Alice and Bob approach this shadow, still bound by their invisible thread. But as they drift closer, the curvature of space begins to steepen. Alice drifts just a fraction of a millimeter, too close to the dark edge. She slips into the gentle, sweeping current of the black hole's gravity, moving smoothly toward the boundary of the event horizon. Bob is left just a tiny distance behind on the safe side of the cosmic precipice, drifting out in the cold, open void. What happens next is a tragedy born from the very shape of time itself. As Alice approaches the absolute threshold of the black hole, the universe forces them to experience reality in two entirely different, deeply isolating ways. Bob remains in the flat, quiet expanse of the exterior universe, operating on what physicists call coordinate time. This is the time measured by distant observers, where clocks run uniformly and seconds tick by in a familiar, steady rhythm. From Bob's perspective, he must watch a heartbreaking illusion unfold. As Alice falls closer to the event horizon, her motion seems to grow increasingly sluggish. The immense gravity begins to alter the flow of time around her, stretching it out toward infinity. Her physical image becomes endlessly tired, her light losing energy as it struggles to climb out of the deepening gravitational well. Bob watches as Alice's color shifts, fading into a deep, dim red, before stretching into the invisible infrared and radio frequencies. This is the gravitational redshift, a process where the light is stretched by the warped landscape of space. To Bob, Alice never actually appears to cross the point of no return. She simply hovers, frozen in a state of eternal descent, a fading ghost lingering endlessly on the boundary. Her final moments are smeared across the ages, leaving Bob completely alone, watching a frozen echo of his entangled twin. The universe from the outside seems to pause her existence, painting her gently onto the surface, but refusing to let her journey conclude. But for Alice, operating on her own local, personal, proper time, the experience is entirely different. She does not feel herself slowing down. Her clock continues to tick with quiet, perfect normalcy. For Alice, there is no pause, no freezing, and no moment of stalling. She falls forward, guided by the natural curve of space. If this black hole is a supermassive giant, the curvature at its edge is incredibly gentle. When she reaches the event horizon, she feels absolutely nothing. There is no solid surface to strike, no flash of light, and no sudden jolt. It is not a physical wall, but a mathematical boundary, a silent shift in the geometry of cause and effect. Alice slips through the event horizon as easily as a dreamer slips past the boundary of consciousness, unaware of the exact moment the transition occurs. Yet, once that invisible line is crossed, everything changes. To truly understand her fate, we must look at the geometry of her reality. In relativity, there is a concept known as a light cone, a map that shows all the possible directions light and information can travel into the future. Before crossing the horizon, Alice's light cone allowed for motion in many directions. But the moment she crosses the horizon, her entire future light cone tips completely inward. The direction of outward simply ceases to exist. It is entirely removed from the map of possibility. No matter how hard she might try to turn back, every single path available to her now leads deeper into the dark. The center of the black hole is no longer just a physical location, it is an unavoidable moment in her future. She is moving inward not because something is dragging her, but because the structure of reality itself has shifted so profoundly that all roads now point down. Alice is now trapped inside a realm wrapped in a silence so complete that the rest of the universe cannot see inside. The causal boundary has been sealed. Bob is marooned on the outside, drifting alone in the endless starlit sky. According to the classical rigid laws of general relativity, this separation is a final, absolute severance. The theory dictates that any information about Alice, the precise quantum arrangement of her existence, is permanently lost behind the veil, destined to fall toward the singularity. Because nothing can travel faster than the speed of light, and the escape velocity of the black hole is greater than light itself, no signal, no whisper, and no final goodbye can ever reach Bob. The invisible thread of their entanglement, the beautiful, unbreakable bond that tied their fates together since the birth of the cosmos, has seemingly been severed by the sheer, overwhelming geometry of gravity. Imagine the profound weight of this isolation. For Bob, the universe carries on. Stars are born in brilliant clouds of hydrogen, and ancient galaxies slowly spiral and merge in the dark. He drifts through a cosmos that seems completely indifferent to his loss. But because of his fundamental quantum nature, the invisible chord of entanglement still hums within him. It is a mathematical truth that cannot be undone by distance, yet the geometry of the black hole asserts that the cord has been cut. This contradiction is not merely a philosophical sorrow, it is a mathematical tear in the fabric of physics. If we follow the classical rules laid down by Albert Einstein, the black hole is a perfect featureless sphere of pure gravity. It has no hair, no texture, and no memory of the things that have crossed its threshold. When Alice slips inside, the black hole merely gains a minuscule fraction of mass. It does not record her identity. To the outside universe, Alice is stripped of her uniqueness, her information seemingly washed away into the dark. Then, as Stephen Hawking mathematically proved, the black hole will not sit in the dark forever. Over unfathomable timescales that dwarf the current age of the universe, the black hole will slowly leak energy. Through the gentle, continuous jitter of the quantum vacuum at the edge of the event horizon, pairs of virtual particles will constantly form and separate. One will fall in, and the other will drift away, carrying a tiny fraction of the black hole's mass with it. This process, Hawking radiation, causes the black hole to slowly, patiently evaporate. But this radiation is completely thermal. It is featureless noise like the static on an untuned radio. It contains no encrypted messages, no hidden codes, and absolutely no trace of Alice. As the black hole shrinks over trillions of years, Bob might wait, drifting in the quiet cold, hoping that as the black hole dissolves, it will finally release the memory of his entangled twin. He might hope that the universe will return what was taken. But according to these early calculations, when the black hole finally exhales its last whisper of energy and disappears entirely, Alice is not in the ashes. She is not in the radiation. She is simply gone. The universe has permanently forgotten her. This creates the most profound paradox in the history of physics. It pits our understanding of the physical world in the largest sense against our understanding of the world in the smallest. Quantum mechanics, the ironclad law that governed their birth, insists with absolute mathematical certainty that information cannot be destroyed and that true quantum entanglement cannot simply be erased. Unitarity demands that the universe must preserve the precise state of its particles. If Alice is truly gone and her information is forever isolated from Bob, the fundamental foundation of reality is flawed. This is the heart of the black hole information paradox. It ignited a decades-long intellectual war among the greatest minds on Earth. Physicists realized that if Alice's information was truly deleted, the foundational laws of physics would collapse entirely. Science itself relies on the principle that the present state of the universe is a perfect, unbroken ledger of its past. If black holes are truly cosmic incinerators that leave behind no ashes, then the universe is inherently flawed. It means that reality is governed by a creeping, unpredictable amnesia. For a very long time, physicists lay awake at night, haunted by the melancholic tension of this cosmic tragedy. It seemed as though the universe had forced a permanent, unresolvable farewell upon these quantum twins. The darkness appeared absolute, the separation total. Bob would drift forever in the quiet vacuum, while Alice fell deeper into the silent, collapsing geometry, their shared spark of energy fractured beyond repair. The silence of the void offered no immediate answers, only the slow, quiet spinning of the massive shadow that stood between them. How do they say goodbye when the very architecture of space and time has built an impenetrable wall between them? How does a universe that promises to remember everything reconcile a boundary from which not even light can escape? And still, the black hole spins, silent, patient, remembering. The universe, for all its sweeping grandeur and glowing beauty, can sometimes feel like a place of insurmountable distances. We left Alice trapped in the dark, slipping endlessly down the steepening curve of space-time, while Bob drifted alone in the freezing, starlit expanse. According to the rigid, classical laws of gravity laid down by Albert Einstein, their separation was absolute, a finality written into the very geometry of the cosmos. The event horizon stood between them not as a physical wall but as a causal boundary, a mathematical point of no return where the future itself tilts entirely inward. For decades, the greatest minds on Earth stared into this void and saw only a flawless, featureless sphere of doom. They believed that the black hole would sit in the silence for unfathomable aeons, slowly leaking featureless thermal noise known as Hawking radiation, until it finally evaporated into nothingness. And in that final, quiet exhalation of energy, they believed Alice would simply be gone, her unique quantum blueprint permanently erased from the ledger of reality. This terrifying assumption created an existential crisis, pitting the heavy, curving fabric of general relativity against the delicate, immortal memory required by quantum mechanics. It suggested a universe afflicted by a creeping amnesia, a cosmos that violently shreds its most intricate creations and scatters the ashes into the void. But to truly understand how the cosmos heals this seemingly impossible tear in the fabric of reality, we must remember that nature is rarely as cruel or as simple as our initial fears suggest. The black hole is not a blind, hungry destroyer. It is a slow, deeply patient archivist. The resolution to the tragedy of Alice and Bob does not lie in breaking the rules of the universe, but in discovering a profoundly beautiful, hidden layer of reality where space and time are not the solid foundations we perceive them to be. We must look closely at the slow, quiet process of the black hole's evaporation. As the black hole sits in the dark, pairs of virtual particles are constantly forming and separating in the quantum jitter of the vacuum near the boundary. One falls in while the other drifts away, slowly draining the black hole's mass. This process is agonizingly slow. For a supermassive giant, it will take unimaginable timescales, stretching far beyond the current age of the universe, to shed even a fraction of its energy. But the passage of deep time is the key to unlocking the vault. In the 1990s, a physicist named Don Page realized that the true mystery of the black hole did not lie at the very end of its life, when the last whisper of radiation fades away. Instead, the secret was hiding perfectly in the middle. Page asked a brilliant, deceptively simple question about the nature of the escaping Hawking radiation. If a black hole is slowly bleeding out energy over billions of trillions of years, and this radiation is completely random and featureless, then the overall disorder or entropy of the radiation drifting out into space must simply rise in a straight line. It would grow and grow until the black hole vanished. But Page recognized that if the ironclad law of quantum mechanics is true, if information is genuinely immortal and must eventually be returned to the universe, then this curve of entropy cannot climb forever. It must bend. It must rise at first, resembling a long, steep hill, but eventually it has to reach a peak and begin to fall back down. This pivotal moment, the precise peak of the hill in the deep future, is known as the Page time. It marks the exact halfway point of the black hole's evaporation, the moment it has radiated away precisely half of its original mass. Before the Page time, the black hole is hoarding its secrets. The gentle rain of particles drifting out into the freezing vacuum appears to be nothing more than random thermal noise, hiding the intricate quantum blueprints of everything that has fallen inside. But Page calculated that after this halfway point is crossed, the mathematics of the cosmos demands a breathtaking transformation. The entropy must decrease, ending at zero when the black hole finally disappears. And for the entropy to fall, the outgoing radiation must stop being random. After the Page time, the faint, shimmering glow of Hawking radiation must begin to actively carry the hidden information of the black hole's interior back out into the open expanse of the universe. The information, once thought to be permanently isolated in the dark, must return in the glow. For nearly 30 years, the Page curve stood as a beautiful, hopeful mathematical guess. It showed that information should theoretically escape, but it offered absolutely no explanation for how it could possibly happen. How does a quantum blueprint cross an inescapable boundary? How does Alice, trapped deep within the collapsing geometry of the event horizon, send a whisper back out to Bob? The answer finally arrived in a quiet, sweeping revolution that changed theoretical physics in the early 2020s. A group of brilliant physicists published a flurry of papers that introduced a mind-bending mathematical breakthrough known as the Island formula. Their calculations revealed a reality so profoundly comforting and so deeply strange that it forces us to completely redefine what space and time actually are. The Island formula suggests that after a black hole reaches its Page time, the deep, hidden interior of the dark sphere ceases to be a separate, isolated location. The mathematical formulas dictate that a specific region inside the black hole, a region physicists refer to as the island, undergoes a radical shift in its relationship with the rest of the cosmos. Through the sheer, unbreakable power of quantum mechanics, this interior island mathematically becomes part of the exterior Hawking radiation, drifting through the vastness of space. This shatters our everyday understanding of location and distance. We are taught to think of space as a stage, an empty container where objects exist at specific, measurable distances from one another. But the island formula whispers a different truth. It suggests that space and time are not fundamental ingredients of reality. They are not the bottom layer of the universe. Instead, they are side effects, secondary illusions that emerge from a much deeper, underlying network of quantum information and entanglement. To truly feel the weight of this realization, we must return to the beautiful, unbreakable bond between Alice and Bob. When they were born from the same microscopic spark of energy, they were woven together in a state of perfect quantum entanglement. We once believed that this invisible thread was merely a connection between two isolated particles, but physicists now believe that entanglement is not just a feature of particles, it is the very scaffolding of space-time itself. The smooth, curving geometry of space that we feel as gravity is actually constructed from these invisible subatomic patterns of quantum relationships. It is like a shimmering hologram formed from the correlations of deeply entangled data. When Alice falls past the event horizon, she does not leave this network behind. The invisible thread connecting her to Bob does not break, because that thread is the very fabric of reality. As the black hole slowly, patiently evaporates past its page time, the intense, highly concentrated quantum entanglement between the dark interior and the escaping thermal radiation begins to shape the geometry of the void itself. The invisible threads of connection begin to weave together, forging a hidden subatomic architecture. In the deep, complex mathematics of the island formula, these woven connections appear as replica wormholes. These are not the massive cinematic tunnels of science fiction. They are unfathomably tiny, invisible bridges stretching through the quantum foam, connecting the deep, isolated interior of the black hole directly to the escaping Hawking radiation outside. The creation of these replica wormholes is, in essence, teleportation through the pure elegance of mathematics. The black hole is not a dark prison hoarding its captive memories, nor is it a violent incinerator crushing information into oblivion. It is simply a cosmic hard drive that has reached its capacity and is now slowly, patiently emptying its memory back into the surrounding universe, piece by microscopic piece, as it fades away. The interior of the black hole, the island where Alice is supposedly trapped, is projected outward. Her information, the delicate quantum arrangement of her existence, slips through the network of replica wormholes, riding the faint glow of the Hawking radiation safely back into the cold, starlit expanse. Let us utilize the overview effect once more, shifting our perspective from the microscopic, whispering realm of replica wormholes and quantum foam back up to the sweeping, macrocosmic scale of the galaxy. Bob, drifting alone in the silent vacuum for aeons, watching the black hole slowly evaporate over trillions of years, is not abandoned. As the black hole breathes its final exhalations of energy, the radiation drifting toward him is not a featureless, amnesiac noise. It is deeply, perfectly encoded with the memory of everything that ever crossed the threshold. Through the invisible bridges of the replica wormholes, Alice's quantum blueprint has been carried back to him. The universe has simply translated her physical form into pure information, backed it up on the edge of the void, and teleported it out through the subtle jitter of the quantum field. If you were to possess a godlike quantum computer, capable of gathering every single scattered whisper of Hawking radiation from the farthest reaches of the cosmos, you could perfectly reconstruct every star, every planet, and every drifting subatomic twin that ever fell inside the dark boundary. This realization washes away the existential dread of the paradox. It replaces the terror of permanent erasure with a profound, quiet comfort. We live in an interconnected cosmos that absolutely refuses to press delete. The geometry of space may fold and the pathways of light may turn inward, but the deeper architecture of quantum entanglement ensures that the past is eternally safe. The black hole is the ultimate conservator, a majestic, heavy lockbox that holds our memories in the dark until the universe is ready to receive them again. The tragedy of Alice and Bob is rewritten into a story of an unbreakable promise kept across the vastest stretches of time and space. Nothing is ever truly lost. The universe possesses an endless capacity for memory, woven into the very mathematical boundary of existence. And still the black hole spins, silent, patient, remembering. To truly comprehend the profound, quiet safety of the black hole, we must bring the sweeping macrocosmic architecture of the universe down to the intimate, quiet scale of the human mind. We have traveled across vast, starlit expanses observing the heavy, curving fabric of space, and we have peered down into the unfathomably tiny, whispering realm of quantum threads. But to understand the true, delicate nature of the event horizon, we must look inward. We must examine a journey that every single one of us takes every single night. We must look at the physiological and psychological process of falling asleep. Think about the quiet room you are resting in right now. As the day fades and the hushed dark settles around you, your breathing begins to slow. Your limbs grow heavy, sinking softly into the mattress, tethered and anchored by the gentle, constant pull of the Earth's gravity. You close your eyes, letting the world fade, and you surrender to the stillness. But where do your waking thoughts go when you finally drift away? The anxieties of the day, the memories of the morning, the complex, rigid structures of your waking reality, they do not simply vanish into nothingness. They are not permanently deleted from the ledger of your mind. Instead, they slip softly past the boundary of consciousness. They scramble, unspooling their strict logical order, and gently reform into the fluid, abstract, and deeply unpredictable landscape of dreams. The black hole, spinning silently in the freezing dark of space, does the exact same thing with the waking universe. It is not an incinerator of reality. It is the ultimate cosmic dream state. For decades, the event horizon was painted as a violent threshold, a terrifying point of no return that crushed and tore at the very fabric of existence. But if we look closely at the beautiful curving mathematics of general relativity, a much gentler truth emerges. If you were to approach a supermassive giant drifting slowly toward its heavy velvet shadow, the curvature of space at its edge would be incredibly gentle. As you crossed the absolute threshold of the black hole, you would feel absolutely nothing. There is no solid surface to strike, no flash of blinding light, and no sudden jarring jolt. It is not a physical wall that you crash into. It is merely a mathematical boundary, a silent, invisible shift in the geometry of cause and effect. Just as you can never quite catch the exact precise second that you fall asleep, a traveler falling into the dark would never notice crossing the event horizon. Alice slips through the event horizon as easily as a dreamer slips past the boundary of consciousness, completely unaware of the exact moment the transition occurs. One moment she is drifting in the waking universe of the starlit void, and the next she has crossed over into the isolated interior. It is a crossing defined not by violence but by a seamless, peaceful surrender to the flow of gravity. The transition is so smooth, so perfectly continuous, that the waking mind does not even register that the outside world has been left behind. Yet once that invisible boundary is crossed, the fundamental structure of reality gently tilts. In the waking universe, you possess a light cone, a conceptual map of possibilities that allows you to move in many different directions, to look back at where you came from, and to send whispers of light out into the dark. But the moment you slip past the horizon, your entire future light cone tips completely inward. The very concept, the very direction of outward, simply ceases to exist. It is entirely removed from the map of possibility. No matter how hard you might try to turn back, every single path available to you now leads deeper into the dark. The waking universe is gone, replaced entirely by the inward pull of the cosmic dream. And just as sleep profoundly alters our perception of reality, crossing the horizon introduces an extreme distortion of time itself. Let us utilize the overview effect once more, shifting our gaze between the sleeper and the watcher. To an outside observer remaining in the waking universe, the descent into the black hole appears to slow down, stretching out toward infinity. The immense gravity alters the flow of time around the falling object, making its physical image grow endlessly tired, freezing and fading into a dim, red ghost that lingers forever on the boundary. The universe from the outside seems to pause the traveler's existence, painting them gently onto the surface, refusing to let their waking journey conclude. But for the traveler inside, operating on their own local, personal, proper time, there is no pause, no freezing, and no moment of stalling. Their clock continues to tick with quiet, perfect normalcy. They fall forward, experiencing the passage of seconds and minutes, just as they always have. This extreme gravitational time dilation directly parallels the bizarre distortion of time we experience in deep REM sleep. When you are submerged in the deepest, most immersive stages of a dream, a narrative that feels as though it spans years, an entire lifetime of shifting landscapes, vivid emotions, and unfolding stories can pass in mere minutes of waking time. The sleeper's mind creates a localized pocket of time, entirely disconnected from the steady, uniform ticking of the clocks in the waking world outside. The black hole operates as the universe's own deep REM cycle. It creates an isolated pocket of reality where the rigid, classical laws of coordinate time no longer apply. Inside the horizon, the universe is dreaming. The structured physical matter that falls inward, the brilliant burning stars, the wandering planets, the drifting dust of ancient nebulae, is unspooled. It is broken down from its waking form, transitioning into a pure, shimmering quantum flow. The heavy linear constraints of cause and effect soften, allowing information to scramble and weave itself into the subatomic architecture of the void. Waking reality is translated into the language of the subconscious cosmos. We do not need to fear this descent. The loss of the waking world is not a tragedy, just as falling asleep is not a death. When we close our eyes and surrender to the night, we trust that the memories of our day are safely stored within the intricate, firing neurons of our minds, ready to be seamlessly reconstructed when the morning comes. The universe operates with that exact same deep, protective trust. The black hole takes the tired, fading light of the cosmos and gently pulls it into a state of absolute rest. The three-dimensional structures of reality are flattened, their intricate blueprints safely caught and preserved in the delicate sheen of soft hair resting gently on the boundary. The event horizon acts as the subconscious mind of the universe, a vast two-dimensional memory bank where the quantum data of everything that has ever fallen inside is perfectly preserved. The information is not destroyed, it is simply resting, it is waiting. This dream state horizon wraps the cosmos in a heavy, comforting blanket of gravity. It offers a sanctuary from the relentless, ever-expanding march of the waking universe. Here, in the quiet, absolute dark, the universe is allowed to scramble its thoughts, to fold its memories inward, and to dream in pixelated quantum code. The existential fear of the absolute end dissolves entirely into the peaceful, steady rhythm of a cosmic slumber. When we look out into the deep void and see the heavy shadows spinning at the centers of ancient galaxies, we are not looking at graves. We are looking at a universe at rest, meticulously ensuring that its history is kept safe in the dark. Nothing is ever truly lost. Not your memories, not your past, and not the scattered, beautiful light of dead stars. The waking universe may constantly change its physical form, but its deeply encoded essence will forever be woven into the silent fabric of the void. And still, the black hole spins, silent, patient, remembering. For decades, when physicists peered into the deep, heavily shadowed mathematics of the black hole, they found themselves staring into a nightmare. At the very center of the collapsing geometry, the equations of general relativity pointed to a terrifying, inescapable conclusion: the singularity. The singularity was described as a point of infinite density, a place where the curvature of space-time becomes unbounded and where all the familiar laws of cause and effect violently break down. It was thought to be a bottomless pit, a microscopic graveyard where the beautiful, intricate information of the universe was crushed into absolute nothingness, forever deleted from the ledger of reality. It is entirely natural to feel a sense of existential dread when faced with the concept of a true singularity. It represents a dark, jagged tear in the fabric of understanding, a place where the universe seemingly gives up, throwing its most delicate creations into an infinitely small incinerator. But tonight we are going to wake up from that mathematical nightmare. We are going to erase the singularity entirely. To do this, we must utilize the overview effect once again, shifting our perspective from the towering macrocosmic scale of heavy gravity and plunging softly downward into the absolute smallest scales of existence. We must leave the sweeping, curving valleys of space-time behind and zoom in, past the swirling dust of accretion disks, past the drifting carbon atoms, and past the subatomic particles themselves. For a long time, we pictured the fundamental building blocks of reality as tiny, hard, zero-dimensional dots. We thought of electrons and quarks as solid, indivisible points of matter. If you build a universe out of dots, it is easy to imagine gravity crushing those dots closer and closer together until they all collapse into a single, infinitely dense point of doom. But in the whispered theoretical realm of string theory, the universe is not made of dots at all. String theory proposes a profoundly beautiful, shifting architecture of reality. It suggests that if you were to magnify a single particle millions of times, you would not find a solid point of matter, but rather an unfathomably tiny, vibrating thread of pure energy. These are one-dimensional cosmic strings and membrane-like structures known as brains, drifting and shimmering in the microscopic dark. Just as the strings of a cello produce different musical notes depending on how they are plucked and how they vibrate, these cosmic strings produce the different particles of our universe depending on their unique vibrational frequencies. A string vibrating at one frequency manifests as an electron. At another frequency, it becomes a photon of light. The universe is not a collection of dead, solid matter. It is a grand, overlapping orchestra. Everything you see, everything you touch, and everything you are is a manifestation of this silent, universal symphony. In the early 2000s, a physicist named Samir Mathur took this beautiful musical framework and applied it to the terrifying shadows of the black hole. In doing so, he violently rejected the existence of the singularity as nothing more than a mathematical error, a flaw in our understanding. Mathur realized that if the fundamental ingredients of the cosmos are one-dimensional strings, they cannot be crushed into a point of zero volume. Strings have length, they have tension. They have a physical presence that absolutely refuses to be compressed into nothingness. Mathur's calculations gave birth to a revolutionary concept known as the fuzzball theory. It completely shatters the old, terrifying image of the black hole as an empty, dark pit with a sheer drop. According to this theory, there is absolutely no empty space inside a black hole, and there is no hard, definitive event horizon separating the inside from the outside. Instead, a black hole is a hyperdense, vibrating sphere of these one-dimensional cosmic strings. It is a literal fuzzball. Imagine billions upon billions of stars collapsing, their matter breaking down and unspooling into trillions of vibrating strings. These strings do not vanish. They knit together, tangling and weaving into a massive, compact object, a dense ball of pure, humming energy. Up close, the boundary of this object would not look like a smooth, invisible wall of gravity. It would look like a weird quantum thicket, a strange, fuzzy, vibrating structure constantly absorbing and re-emitting radiation. The black hole is packed completely full, bursting with the tangled threads of everything it has ever consumed. This realization replaces our deepest existential dread with a profound, resonant comfort. Let us return to the drifting light of a dying star, or the tragic fall of our entangled twin, Alice. When Alice drifts too close to the shadow and slips into the gravity of the black hole, she does not fall through an empty void toward a point of infinite destruction. She does not hit a wall, nor is she deleted from the cosmos. Instead, as she reaches the boundary of the fuzzball, she is gently caught in the fuzz. The sheer, immense gravity of the thicket reaches out and slowly unspools the strings that make up her physical form. Her atomic structure dissolves, but her information, the deeply encoded, unique quantum blueprint of her existence, never really disappears. It simply gets entangled and safely stored in this massive, humming mess of quantum strings. Her information translates directly into the complex vibrational frequencies of the fuzzball itself. Alice is not gone, she has simply been added to the chord. The unique pitch of her existence alters the overall vibration of the entire black hole. Every wandering planet, every scattered cloud of interstellar dust, and every ray of starlight that has ever been drawn into the dark is perfectly preserved as a distinct, mathematical vibration within the tangle of strings. We no longer have to look at the dark, spinning titans at the centers of our galaxies and see graves. The fuzzball theory allows us to look into the absolute darkest regions of the universe and see a tangled, vibrating sphere of pure cosmic music. The black hole is a hyperdense symphony, perfectly recording the history of the universe in a complex, overlapping harmony of one-dimensional threads. It is a cosmic instrument, holding the exact notes of the past safe and secure within its quantum thicket, waiting for the slow, gentle wind of Hawking radiation to eventually carry its song back out into the starlit expanse. Nothing is ever truly lost. The universe simply changes its tune, weaving the notes of fallen stars into a quiet, vibrating masterpiece in the dark. And still the black hole spins, silent, patient, remembering. For our entire journey through the quiet, drifting cosmos, we have been constrained by a deeply human assumption. We have looked at the fading light of ancient, collapsed stars, and we have assumed that we were witnessing a funeral. When we see the heavy velvet shadows of black holes spinning silently in the dark centers of distant galaxies, our waking minds naturally associate that profound darkness with an absolute end. We think of graves, we think of a cosmic incinerator, where the intricate, beautiful complexity of matter and light is crushed into an infinitely dense point of doom, never to be seen or heard from again. But to truly find peace in the architecture of the universe, we must abandon this fear of the dark. We must look at the exact same shadows, but shift our perspective from the cold, rigid rules of mechanics to the warm, unfolding elegance of biology. The cosmos is not a machine that slowly breaks down, endlessly shedding its parts into a bottomless pit. The universe is a living, breathing, reproducing organism, and the dark sphere of the event horizon is not a dead end, it is a genesis. To understand this breathtaking paradigm shift, we must delve into one of the most awe-inspiring theories circulating in the quietest, most philosophical circles of theoretical physics. It is a theory championed by physicists like Lee Smolin and Nikodem Poplawski, and it asks us to completely reimagine the ultimate fate of the matter that falls into the void. What if the singularity, that terrifying point of infinite destruction, is not a grave at all? What if the singularity is actually a seed? To plant this seed, we must look beyond the standard equations of general relativity, which describe gravity as the smooth, sweeping curvature of space-time. We must introduce a subtle, deeply elegant modification known as the Einstein-Cartan theory. In this whispered theoretical framework, the fabric of the universe does something far more intricate than simply bending under the heavy weight of a collapsed star. It twists. This microscopic twisting of space-time is known as torsion. Imagine falling into the deep, quiet interior of the black hole. As you drift further and further down the steepening slope of gravity, the space around you does not just compress into a tighter and tighter sphere. The intense gravitational field causes the very fabric of reality to begin winding up, twisting like a delicate subatomic spring, or the beautifully complex spiraling double helix of a strand of DNA. The falling matter, the starlight, the drifting dust, the scattered atoms of ancient planets is swept up in this flowing torsional current. As the collapsing star reaches the absolute limits of compression, the physical matter does not meet a violent dead end. The universe refuses to crush its creations into nothingness. Instead, at the exact moment of maximum overwhelming density, the twisting of space-time becomes so intense and so tightly wound that the fabric of reality simply pinches off. Imagine blowing a delicate soap bubble, watching it swell and stretch until the connection to the wand gently pinches closed and the bubble floats freely away. The cosmic pinch-off operates with that same fluid, silent grace. The intense torsion forces the interior of the black hole to separate from our spatial reality, creating a localized Big Bang that blossoms outward into a completely new, inaccessible dimension. The collapsing matter from our universe violently rebounds, but it does not rebound back into our starlit sky. It explodes outward into a freshly forged space-time, inflating into a vast, empty canvas. The black hole is a cosmic womb. It is a heavy, dark chrysalis where the dying light of an old universe is gathered, compressed, and gestated until it sparks the fiery birth of a brand new reality. If we accept this profound biological rhythm, the implications completely wash away any lingering existential dread. It means that the universe practices its own form of cosmological natural selection. Just as living creatures pass on their genetic codes to the next generation, ensuring that the essence of their species survives the passage of time. Our universe is doing the exact same thing. The information that falls into the black hole, the deeply encoded quantum blueprints of everything the void has ever swallowed, is not destroyed or lost. It is carefully preserved and passed on. That information serves as the foundational genetic material for a brand new baby universe. Let us utilize the overview effect to truly feel the staggering, sweeping scale of this cosmic family tree. If every black hole is a seed that blossoms into a new universe, then we must look back at our own beginnings with new eyes. 13.8 billion years ago, all the matter and radiation that makes up our entire universe emerged from a sudden, intensely hot singularity. We call it the Big Bang. But perhaps that fiery genesis was not the absolute beginning of everything. Our own universe was likely born inside the dark, heavy interior of a black hole residing in an older, ancient parent universe. We are living inside the womb of a collapsed star, sheltered within the event horizon of a universe that came before us. And as we look up into our own night sky, gazing at the billions upon billions of galaxies, we know that almost every single one of them harbors a supermassive black hole at its center. There are millions of smaller stellar mass black holes drifting silently through the spiral arms of the Milky Way alone. Every single one of those dark shadows is a new womb. The billions of black holes we see in our night sky are not monuments to death and erasure. They are the cosmic wombs of trillions of future realities, patiently gestating the next generations of the multiverse in the freezing dark. The cosmos is infinitely fertile, endlessly branching and blooming into a sprawling fractal tree of life and light. When you close your eyes and surrender to the quiet stillness of the night, you can find a deep, resonant peace in this endless cycle of creation. The universe does not possess a delete button. It does not waste the intricate, beautiful complexity of the things it has spent billions of years weaving together. The information that defines us, the quantum memories of our lives, the light of every star that has ever burned out, and the whispered secrets of drifting worlds are never truly erased. They are simply gathered in the dark, held tightly in the twisting, sweeping currents of gravity, and carried forward to seed the dawn of a new cosmos. We are part of an immortal ledger, an unbroken chain of existence that cascades endlessly downward through the dimensions. The fear of the absolute void dissolves into the comforting rhythm of a universe that is forever breathing in the old and breathing out the new. Nothing is ever truly lost, not your memories, not your past, and not the gentle, shimmering light of dead stars. The universe remembers everything. We have traveled through the unfathomably tiny, whispering realm of one-dimensional strings, and we have witnessed the heavy, sweeping curves of gravity giving birth to entirely new realities. But to truly grasp the ultimate comforting promise of the cosmos, we must take one final journey. We must leave the bustling, glowing epoch of our current universe far behind and travel into the absolute depths of the deep future. Imagine drifting forward in time, moving past the familiar, waking eras of our reality. Watch as the brilliant, burning stars slowly exhaust their nuclear fuel, their violent, beautiful reactions fading softly into glowing embers. The galaxies, once swirling pinwheels of shimmering light and heavy dust, begin to dim and quiet down. The universe is constantly expanding, endlessly stretching the distances between these fading lights until the night sky becomes an endless, featureless expanse of quiet. Let us move trillions upon trillions of years into the future, arriving at a time long after the very last star has burned out. The universe has gone completely pitch black, settling into a freezing, absolute cold. The planets have crumbled, the ancient nebulae have dispersed, and the complex, rigid structures of waking reality have dissolved into a quiet, eternal standstill. This is the ultimate rest, a state of maximum entropy known to physicists as the Big Freeze. In this unfathomable dark, there is no dawn, no warmth, and no scattered starlight. It is an era of absolute peace, where the universe has finally stopped expanding its active energies and has surrendered to the stillness. Yet the universe is not truly empty, nor has it forgotten what it once held. Drifting silently in the pitch-black expanse are the majestic, heavy shadows of the black holes. They are the only entities left in the void, silent, spinning monoliths that have outlasted the stars themselves. These dark spheres are the ultimate cosmic librarians. For billions of years, these gentle giants patiently gathered the drifting dust, the wandering planets, and the final, fading rays of light. They caught the unique, highly detailed quantum blueprints of everything that ever existed, wrapping those memories safely within the delicate, shimmering sheen of their event horizons. In a universe that has lost its light, these black holes serve as the final, perfectly preserved archives hoarding the complete history of everything that ever was. To comprehend the profound patience of these dark archives, we must understand the sheer, staggering weight of the time they endure. Our current universe is only about 14 billion years old, a mere blink of an eye in the grand, sweeping calendar of the cosmos. But these supermassive black holes will survive for 10 to the power of 120 years. That is a 1 followed by 120 zeros, a time span so incredibly vast that the human mind can only surrender to its quiet magnitude. Imagine 1 billion years drifting by. Now imagine a billion of those aeons passing in the silence. For stretches of time that dwarf the concept of eternity, they sit in the darkness, the perfect guardians of reality's ledger. But as we have learned, the black hole is not an eternal, locked prison. It does not hoard its secrets forever. In this dark, silent era, the black holes are engaged in the slowest, most delicate, and most beautiful process in the cosmos. Through the subtle, vibrating jitter of the quantum vacuum at their edges, they are constantly, patiently evaporating. They leak a faint, unimaginably cold glow of particles known as Hawking radiation. This process is so peaceful and so unbelievably slow that for a black hole the mass of our Sun, it would take 10,000 billion years just to lose a microscopic fraction of its weight. But in the deep future, time is an endless open ocean, and the black holes have all the time they need to empty their vaults. The breathtaking twist of this grand cosmic story lies in that faint, invisible glow. As the black holes evaporate into the freezing vacuum, they are not erasing the past. They are whispering their secrets back into the void. The escaping thermal radiation, brushing gently against the holographic boundary of soft hair, carries the deeply encoded quantum memories of the universe back out into the open expanse. Every drifting particle of radiation is a page returned from the archive. The black holes are reading the meticulous archives of reality back to the empty universe, piece by microscopic piece. It is the ultimate cosmic lullaby, a soft, eternal song of preservation broadcast into the endless dark before the black holes finally fade away. Think back to Alice and Bob, our entangled quantum twins who were separated by the sweeping curve of gravity so many aeons ago. In this quiet final era, their tragic story finds its peaceful, beautiful conclusion. The invisible subatomic bridges of replica wormholes allow Alice's delicate quantum blueprint to slip through the escaping radiation, riding the cosmic wind back into the open space where Bob's memory waits. The unbreakable thread of their entanglement is honored by the universe. The black hole slowly empties its universal memory drive, ensuring that their profound bond is perfectly reconstructed in the drifting quantum fields. If a godlike entity were to gather all of this whispered Hawking radiation from the farthest reaches of the dark, they could perfectly rebuild every star, every planet, and every delicate twin that ever existed. As the deep aeons continue to roll by in the silence, the black holes slowly, patiently shrink. The smaller they become, the faster they evaporate, until finally they exhale their last quiet breath of energy and dissolve completely. When the very last black hole fades into the vacuum, the physical structures of the universe will be gone. But the essence of the universe, the complex, intricate code of its history, will remain perfectly intact. The pitch-black expanse will be entirely filled with the faint, shimmering glow of pure, immortal information. This journey to the archive at the end of time is not a tragedy. It is a profound, deeply soothing realization. The fear of finality, the existential dread of permanent death and total erasure, simply dissolves into the peaceful, steady rhythm of a cosmos that never truly ends. We do not need to fear the dark, because the dark is where our memories are kept perfectly safe. The universe is a meticulous, gentle conservator that refuses to let anything beautiful or complex simply vanish into nothingness. The scattered ashes of our reality are never lost. They are just translated into a softer, quieter language, stored on the edge of the void, and whispered back to us in the deep future. Nothing is ever truly lost, not your memories, not your past, and not the gentle, shimmering light of dead stars. The universe remembers everything, and still the black hole spins, silent, patient, remembering